Hello, viewers. Welcome to SCALE Conference 2026 Mumbai. Today we have a very interesting guest with us.
Hi, my name is Onkar. We are from Craste. We work with crop residue upcycling. We build carbon negative building materials that are direct alternatives to timber and timber based products like plywood
Okay.
and virgin paper.
Okay, so you are making wood without tree.
Correct.
So what is the raw material here?
So, raw material is essentially agri residue. After harvesting, the material that is left on the ground that the farmer has no option but to burn it.
Uh-huh.
And people consider it as a waste, but it is a very potent material that has a lot of
Useful properties?
useful properties. Can be converted into materials like pulp, paper, packaging, boards.
Uh-huh. Okay, so why do this rather than just like consume normal wood? Like what are the pros and cons of doing this approach where you are taking agricultural residue, which again, farmer just wants to burn.
Correct.
Why would you go and pay them and then collect this? Like what is the thought process behind it?
Correct. So this is considered as a waste material, right? The farmer has very limited time to clear out the field for the next sowing cycle. And easiest option for him is to burn the fields, right? But we come in with a model of incentivization. We basically give some value in return of the material so that the farmer is basically motivated to be a part of this journey, right? He understands that this material can be used for a greater good. The waste can be a direct replacement to timber, right? You know, deforestation has its own hazards, right? We're talking about. It's okay.
Keep trying.
We're talking about utilizing a material that has no value, and we pay the farmer, incentivize him, get him on board, and build something of value.
Okay, so when you are making this sort of board, how close this is to like what I can get on the store, so to say?
So in terms of properties, this is very superior as compared to conventional composites, right? It's comparable in terms of it is a direct replacement to plywood, as I said. If we talk about flexural performance, bending, it's higher than a standard HDHMR board. If I have to talk about bonding, the bonding that basically defines how the material holds together in tensile strength, it is better than plywood. Screwing is also better
Okay,
than plywood.
why it's better than plywood if it's using inferior material in contrast compared to virgin wood, so to say?
So this is where our glue comes into the picture. These boards are made out of a glue that is formaldehyde free, which is also a novelty of our product. Conventional composite board industry uses a glue that has formaldehyde in it. It can be urea formaldehyde, melamine formaldehyde, so which is a cancer-causing agent, right? So our novel glue that we use is basically free of formaldehyde. It penetrates directly into the fiber and gives superior strength at lower dosages.
So yeah, basically this bonding agent is superior than what is used by normal plywood.
Superior and environmental friendly, lower emissions.
Okay, so how much material do you have? Like, can you actually make a dent in like deforestation or wood consumption? Do you have enough raw material for this?
We do. So we work with a concept of decentralized manufacturing. We are our aim is to set up multiple facilities close to the farms. Our aim is to set up a factory at the farm rather than getting material to somewhere at a mega facility.
So the idea is every state might have some.
Every state or every village, for that matter.
Village would be like, wouldn't that be too decentralized if you do that?
So yeah, we have to define our limits. Basically, a 100-kilometer procurement radius can be a good thumb point to start with, right? So whatever material is available, a standard factory will consume around 30 tons of material per day.
Okay.
That's like 10,000 tons of material every year from one facility, right? So that's a significant contribution to crop burning prevention.
Okay, when you're talking about this material, inherently this has this one issue that wood, we know what we want. We plant the wood and then we harvest it. But when you're talking about agricultural residue, it's free from your control. You do not control it because a farmer might plant the same crop, they might plant something different, and some season might not yield enough results, some season may have like surplus. So how do you balance that variability and how do you make sure that customer that is buying this does not get affected by it?
Right. So we do not rely on one crop, as I said. So there are multiple sowing cycles, multiple crops that are available throughout the year. So our R&D team has developed products that are not dependent on the raw material. Basically, the end performance is something that can be altered with the help of our manufacturing process. Even though the color texture might differ slightly, but we make sure that the performance is not compromised, whatever be the material.
Okay, so you do not have to worry about like, okay, like if some customer is trusting you,
Yeah.
you can deliver them without like, oh, sir, I'm sorry, this season we had flooding or this, we have, like you have some buffer there.
Yes.
Okay, so where is your first plant that you built?
Right. So our first pilot plant is based in the state of Madhya Pradesh. It's called Murena.
Uh-huh.
Murena, Madhya Pradesh. That's where we've established our first pilot plant. It's basically a mustard belt.
Uh-huh.
And the primary raw material, as I said, there is mustard, which is available for almost 4 to 5 months.
Okay, so talk about like whenever we are making about something from biodegradable material, that biodegradability also becomes an issue for the customer. It's like, let's say I bought what you call a furniture from it. I do not want it to dissolve in water, or I do not want termites to harm it or something like that. So how does this hold up against time?
Correct. So we talked about bending, the bonding strength, right? The glue that we use penetrates directly into the fiber, does not leave pores open for the termite to go inside, right? That's the first point. Secondly, these materials have something called as silica. Silica is a natural fire retardant and also prevents termites, right? We also make sure that these boards are mold resistant, fungal resistant, and as I said, fire retardant and water resistant.
So it's not gonna catch on fire if a minor incident happens. It's like it can hold its own.
Yes,
it's
it will
safe
not
enough.
propagate the fire.
It's safe enough that if you're having normal wood furniture, this is not adding to it. It's not like, okay, you have this, now it's a fire hazard. It's not that. It's like it's not gonna care. Like if you are comfortable with wooden stuff, you are comfortable with this.
Yes, it's actually better than wood. Wood is basically gonna propagate fire. Right? This will not. It will create charring. It will not
basically
let the fire
do its best to resist it.
Correct. It will form a layer on top that will cause charring. It will not let the fire propagate to the next furniture piece or whatever is there in the lab. So that's a property that we get through silica.
Okay. So mixing silica allows you to have this sort of system.
Yes, and some additives from the process.
Are there any customers for this, like that have already?
We have worked with a lot of architects, interior designers. In Mumbai, we've made the ICSA boardroom here. We have a market business team sitting in Bangalore. We do a lot of business there. And we're also expanding in other states and other regions.
Okay. So what is up next for your company?
Right. So currently we have like this. We do an event or a competition called Agri-Craft for the students of design colleges every year. So this year it's the second edition, right? And that is a way to promote materials, sustainable materials in design, right? Make beautiful furniture pieces for interiors and also that are functionally, have perform in terms of functionality. So that is something that is happening right now, and we are looking to scale, as I said. So our first pilot is in Morena. We've already scaled up with a third-party manufacturer, and we are looking to onboard multiple of those and try to utilize as much the waste, as I said, as much of it as possible, and build materials that can replace timber-based products.
Okay, are you planning to expand from your waste collection from agriculture to something else like clothing and all that?
We have made boards using textile fabric. That was thrown away by the tailors and all of that. So the best part is you do not have to separate polyester. People talk about recycling polyester being an issue, right? So the best part is you can use all of the material irrespective of
blend of the cotton or something like that.
Yeah, and manufacture boards again that are as strong as ply.
And okay, but cloths are flammability, same question.
Correct.
Is it same resistance as other things, or like
we modify our processes? There are additives that go that prevent flame propagation.
So if you have clothes in your house, which most likely you do not have to worry about it.
Correct.
But again, you also reduce a big waste sector.
Correct. So this is a different type of pollution. Basically, it goes into the landfills.
Yeah, definitely.
Water pollution, leachates.
So the idea with your company is that you have a waste. Why not use that waste?
Correct.
And if that waste can reduce fresh wood requirement, that's good for everyone. The farmer gains some money rather than just matches, fire, the end. you are giving them some what you call incentive and actual money. It's like, okay, it worth it, because again, it will require some labor, because again, a fire is free. So you just set it fire and forget about it. But it will require some labor.
Right.
So you do have to give them some compensation to do those labors and all that.
It's a significant compensation, I would say. So an average farmer, if he has 1 acre of land, 1 acre would yield 3 tons of this agri residue. Even if we're paying 4 rupees, 5 rupees per kg, that's almost 30% of income that he gets from harvesting. I mean, selling his crop. So that's a significant.
And again, you do not have the same penalty as sugar people, where it's like it will only work with one system. That ethanol damage, you do not have that. You are flexible, as in like you do plant whatever you want, maintain your normal crop cycle, and we can work with whatever you are producing. So have you, can you give me an idea like what sort of materials you have tried this with, like agricultural materials?
So you see, this is mustard. We've tried mustard. We have rice straw that is here. We've tried corn cob. Right, you eat corn and you throw away the cob. This is made out of corn cob. Yeah.
So, do you tailor the properties of this, or like do you try to make one material? Like, what is your aim? Like,
so we try to meet the benchmarks that we've set. So we follow a certain standard that the industry needs. Right. So we try and meet the benchmarks by altering the processes slightly. And we make.
So whenever you're talking about processes, like, are you applying a lot of pressure into this to make them?
The standard is basically it's a hot compression process. There is
hot. What sort of temperature we are talking about? Like,
it's around 150, 170 degrees Celsius.
Okay, so not industrial hot, like 300, 500 degrees Celsius.
No.
It's just like okay. Another aspect, let's just say you made it. Nowadays, people want to do a lot of artwork with their wood and all that, so they use laser cutters.
Correct.
Is this stable for laser cutter and all that?
Yes. So we've tried laser cutting CNC. I don't see a photo here.
Okay, just talk about
it. So laser cutting, laser printing, as I said, it does not burn. It chars. That is basically what laser printing needs.
So you are etching it also, so you can add pattern to it, and you are also able to cut it.
Yes.
Have you actually tried it?
Yes, we have. So the density makes sure that the material does not fray. When you do CNC, the cuts are clean and as good as MDF.
Okay. So your end game is to basically reduce waste, reduce fresh wood consumption, give farmers an incentive to not set things on fire.
Yeah.
Okay.
And build materials that are carbon negative. So each kg stores almost 1.3 kilograms of carbon dioxide emissions.
How 1 kg can store 1.3 kg?
So they're called greenhouse gases, basically methane. And,
okay. You are adding methane into it. That's why.
So it's called CO2 equivalent.
Okay. Okay. So specified CO2 equivalent. It's not breaking law of physics.
So it's whenever we define carbon emissions, it's defined in terms of carbon equivalent CO2.
Okay. Yeah, I was like, okay, how the heck they are reaching that system? Okay. So tell us, how can people reach you?
Right. So you can write to us on our mail. You can check our website for further information. You can see our Instagram page. Right. Yeah.
Okay. So this was very nice talking to you, and I hope all the success. I would like a furniture made out of cloth. That would be very unique. So this was a very unique approach of solving a waste issue. So rather than just burning it and causing pollution in Delhi, what if you utilize it and make profit from it? And everybody wins. This is a win-win-win scenario. It's not like, okay, one is winning, another is losing. It's like everybody is winning. So, and again, environment is also winning by secondary order effect, so to say. So this was a very unique company, I have to say. It's one of the unique ones that I've seen. So this was a very nice talking to you.
Thank you.
And I hope your company succeeds.
Thank you.
Thank you.